It's already 2 o'clock. We need to start baking the cakes for Kyle's Zoom birthday party for each of the guests.
How many cakes do we need to make?
About 20.
Then we better get to work.
Let's work on the first cake to determine the kinetics of reaction mechanism.
The first elementary step in this mechanism is cake batter to cake. That elementary step took about 45 minutes. The next step in the mechanism is cake to iced cake. That step only took about 10 minutes. The final step in the mechanism is iced cake to box cake, which should take about 5 minutes. Once it's boxed, we'll be ready to deliver the cakes to all the party guests.
This whole process took like an hour. There's no way we're gonna finish all these cakes on time.
Let's look at the mechanism as a whole to see if there's any way we can speed this process up. So, the first step in the mechanism is cake batter to cake. And since this step took about 45 minutes, it's the slow step in the reaction. Then, the second step in the mechanism is cake to iced cake, which is also a relatively fast step since it only took 10 minutes. Finally, the third step in the mechanism is iced cake to boxed cake, which is also a fast step. When we add all of these elementary steps together, the overall reaction is cake batter to boxed cake. And since we see this reaction mechanism, we know that both cake and iced cake are just intermediates in the reaction since they don't show up. Once we look at the overall reaction, we see that the rate law is rate equals K times the concentration of cake batter. From this rate law, we see that the reaction is first order with respect to the amount of cake batter. And if we want to speed up the cake making process, we need to find a way to speed up the rate determining step.
Now that we understand the mechanism of this reaction, we can finish all the cakes on time.
Yay!
Yay!
Happy birthday, Kyle!
Thanks, guys.